So on the bench, I'm finally taking a closer look at this MITS 88 SIOB card. It's a serial TTL card. So it's an original card. It's pretty cool. It's in good shape overall. Date code on the UART is 12th week of 76. A lot of the TTL logic is in ceramic packages, 76, 16th week 76. So it's definitely from, mid 70s. I'm going to remove this level translator from it. I think that's the first thing I'm going to do here. It's just an ugly, ugly kludge. Try to be careful here not to lift traces. Based on the fact that that's connected to power rails, here's the -12 pickup. I'm guessing it was used as a level translator to convert it to EIA. But in this case, I'm just not going to use that for now. It's interesting that this hole here is actually plated through. So it's an intentional hole on the board. I think the next thing I'm going to do, just because I can't stand the way it looks, is remove all these jumper links and put in pin headers, and then I will wire wrap those connections. It'll be less authentic to the original build, but it would be much more consistent with how I would have built it originally. To do this, I'm just going to snip all these. These are probably bell wire. They're very oxidized copper. I need the other pair of flush cutters. That pair's about shot. It's got a nick towards the end where I abused them. Some of these I can remove from on top, I think. Some probably not. Let's see if I can get these cleanly out of here. Of course, if I can get a hold of it. Just really hate something this clumsy that's already had. I think the foil lifted, or maybe not. We'll come back around to it. Well, the insulation melted and came off the wire, but the wire didn't lift out. Probably be easier with a little pair of tweezers. So let me give that a shot, see if it'd be easier to get in there and manipulate with a pair of tweezers. I've debated whether to completely strip this card down to get the foil pattern off of it. think I'm going to do that. Can I actually solder these from the front? So this strip I'm working on down here is where you set the baud rate. There's a bunch of prescalers, and it's whether you set them, plus or minus. These are lifting out very easily. Trying to somewhat respect the silk screen here. It'd be really interesting to ultimately use this card as the TTY device. That would be very historically correct. That one looks like it need to be pulled by desoldering from the back. I am on an anti-static work surface, and yes, that U-arc, these pins are going directly to that U-arc, at least some of them are. See if I can get that to release. Doesn't look like it. I think those are going to need to be pulled from the back side. Some of these have enough solder on the front side that I can do what you see me doing here. Others don't. Not enough solder on the front side for that to melt through. Probably not on this one either. Oh, came out. The wire is really in the way. I'm just going to lift that wire out for now, rather than take a chance on melting it. burn myself. Sorry, apparently I'm focused and can't talk at the same time I'm focused. Hopefully this isn't too boring. Let's see if we can get those lifted up out of there. Add some solder. And I believe that's removed all the old jumper links. I need to tuck this wire off someplace. I will solder vac those out. So yeah, you set the port address over here. You've got A7 naught, A7, A6, A6 naught, etc. coming down. You've got alternating +5 and grounds that jumper down to the prescalers here. Most prescalers get wired according to this diagram, and I'll be wiring 9600 baud. And then you've got number of parity bits, number of stop bits, number of data bits, 1 and 2, and parity auto control. And again, I think for all these I'm just going to solder in pin headers. Takes a bit away from the absolute vintage look, but I do think it'll look a lot nicer to my eye if when I'd assembled this card, you know, had I been the original assembler, had there been pin headers in my parts, I would have used them. And hopefully I can get this to clean up without lifting pads. Shot a little hot ball of solder out the other side and directly into my finger. That hurt. Ouch, did it again. Ow, what the hell? That really hurts. Are we getting... Yeah, tool needs to be cleaned again. We're getting a bit of back pressure blowing out through the little vent, or the little intake hole. So let's do a bit of maintenance on the tool. Well, not as bad as I thought. Although the ceramic filter is absolutely shot. It might be time if I can find it. it's time to substitute this. Scissors, wherever they went. Awful big package for a very small part. So I ordered a replacement barrel, and you can see just how nasty this old barrel is. It's seen a lot of use. A lot of use over the years. Go ahead and clean this up a little bit. Man, that really hurt. Get this to drop down into place. Went right in. Ceramic filter. Back into the tool. Let the tool heat up for a minute. Maybe it'll work a little better now and not burn me. That really hurt. That little ball of solder it spit out twice. It was definitely painful. I'm not used to having the tool spit like that. That was not fun. Pretty grubby on this side as well. It's not sounding quite right to me. Well, it's definitely open. We've got a set over here. Man, that is really determined to spit little balls of solder out. Maybe it's always done that. I just hadn't noticed. That looks pretty good. Well, it's not horrible. It's not awesome. It looked like these were on 0.1 centers, and they are. So I'm sitting here debating now, pin headers, or just redo the jumpers and do them a little cleaner. Make them look a little bit cleaner. The board definitely has more charm using wire jumpers. If I got anything in here lengthwise that'll work for some of these. That's way too big. That's a good size. Not as good a size. A little too long. Way too long. Rings would actually work along there, and I need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of them. I don't honestly think I have that many here. At least links of that length. No more O-rings floating around in here. Short. I do have another one of these someplace. 1, 2, 3, 4, 5, 6, 7, 8. I need 4 more. And over here, the yellow is just a little too long. Again, it would be O-ring spacing over here. I'd need 8 more there. I'm just not going to have enough of these at that length. Of course, I can bend the yellow ones. Which doesn't look half bad. I don't know, what do you think? Pin headers, wrap wire, wire jumpers, which I will concede is much more historically accurate, but by cleaning them up. Went to the wrong spot. . course, before I solder these in, I need to think about what port I want this strap to. That's certainly not bad. It looks much more authentic. I think I determined up here. I've either got to jump short, like so, or I've got to jump fairly long. Like so, and I've actually got good lengths that'll work for that. For both of those. So really maybe jumper wires are the right answer here. It looks a lot more authentic. I originally used jumper wires. I've got some good lengths here to work with. If I can find the other one of these. I think I know where it's at downstairs. I'll have enough orange links. Yeah, it's going to be wire jumper links. That's just the only way to do this and have it look very vintage. Anyhow, we'll pick this up in a second once I go find the other jumper links. So, found the other little container of jumpers. Let's just go ahead and continue here. Get this guy all nice and jumpered up. For now, I'm going to strap A7 to A1 all to ones, and that'll put it at port 254 and 255, and that should work for testing. And then I will need to rearrange these jumpers if it actually works, to get it down to what is it, 16 hex, I believe, or 16 octal, I don't remember, to the actual port that's assigned to the TTY. So these will need to be changed again. But for testing, this will work. Get these bent over a bit so they don't fall out. Maybe. Kinds of little bits of solder that got shot out of the soldering pump. That's really unusual. I'm not sure why that's happening. I don't think that's normal. Yeah, keeping this more historically accurate is the right call. Not meant to look all modern. I did jump those all to, yep, to the, not to the knotted addresses, but to the actual addresses. So to A7 to A1. See if we can get these to solder up. That one did not solder well. There it is. That one was a little high, and it is. They are close enough. those are taking solder as well as I think they should. I guess they're okay. I think that looks decent. Now for the baud rate generation. Let's see. Sure, here's some place it said that one was, plus. So for 9600, we've really got the 3 down here on the end that go to ground. And so we'll take care of those first. And that is a ground there. And that is a ground there. Yes, all 3 of those look to be going to ground. So the pads here are ground plus, ground plus, ground plus, ground plus all the way across. And so these 3 bits are being hooked to zeros or ground. So I'll go ahead and solder those up. And the rest of them get set to 1s. That didn't take solder at all. There it went. And the rest of these get tied to plus. Let's see, positive is there. So let's come over to this end and start. So that's the positive, and that way they'll all be the same spacing. Yeah, this for me looks a lot better and is historically accurate. And assuming the manual's correct, there's 2 different charts for setting these jumpers, and this one seems to be the correct replacement for the one in the manual, the original one that was wrong. And that must have been really interesting for some people. 9600 baud back then was pretty screaming fast. So let's see, all ones except for the last three that are grounds. Yep. These, hopefully I'll never have to change again. So once they're in, I won't take a chance on damaging the PCB. It's got a resistor. That's a pull-up resistor. And I'll come back and touch up that solder joint. I accidentally melted some plastic against the soldering pencil tip, and it still smells like plastic burning. That's a really lousy looking solder joint. This tin plated jumper wire is not taking solder as well as I would have liked. I'm not really sure why that is. Oops. Missed one. I'm expecting a delivery today, and that's a tow truck out there, not FedEx. Yeah, that's a really lousy solder joint to that resistor. So that gets our jumpers in for baud rate selection, and finally we move on to programming here. So number of data bits is going to have NB2 and 1 tied high. I know I determined there was a length here that seemed to fit. That looks too long. I don't remember what length it was. Shorter than the green. Was it the yellow? Yes, number of data bits 2 and 1. We're going to go to the yellow. We're going to go to plus a number of data bits, high, gives me 8 data bits. And that's what we want there. So I want no parity, so that is NBP. NBP, when tied high, eliminates parity. So I need another yellow wire. So NPB eliminates parity, and we're doing 8N1, so 8 bits, no parity, 1 stop bit. When tied high, so we want this guy right here tied high. Where'd it go? Tied high. We've got NSB, number of stop bits. When tied low, 1 stop bit. And we do want it tied low, and I believe we determined the red jumpers were a good length for that. That is NSB, number of stop bits. When tied low, 1 stop bit. Jeez. Flipped the card over and completely lost again where I was soldering. And POE. If NBP is tied low, POE defines whether parity will be odd or even as shown below. POE unconnected doesn't care. So the question becomes, do I even want to put a jumper in there? If it's low, and it's the 8N1, 8-bit, no parity, 1 stop bit. I hate to just leave it floating. So I'm just going to go ahead and strap it low even though it's not used. Just so it's not left floating. So we're tied to A1 through A7. This gets me port 254, 255 decimal. We are all ones with 3 zeros. And zeros on this end all the way up to 11. 3 zeros, all ones. We have NB1 or NDB1, NDB2. Both set to 1, so that's 8 bits. We have NBP tied low, no, and NSB, let me find the right signal here, NSB tied low, NSB is tied low as 1 stop bit, and NBP eliminates parity from being transmitted when tied high, and it is tied high. So we should be good. The last thing to do is to put back in the wire I removed. For that I need to heat up the soldering pencil again here. that's heating, or this solder removal tool. Get these closed back up. Oh, missed a couple. And I like that a lot better than pins and wire wrap. It looks a lot nicer. So we need to reconnect that wire to H over here, which is right there. I'm going to add a little bit of fresh solder before I clear out the hole. If that's come up to temp, yeah, it has. Let's clear out the hole. And take the wire that we secured out of the way. That wire is just barely long enough to fit. That'll stay there while I solder. Find out. No, it fell out. Okay. We'll, let me add some more solder here on top. And we'll just push it down through and hold it. And we've got the card jumpered. We've got a 5-volt out of ground. Now, this has got to be receive, RSI, and TSO transmit, serial out, receive serial in. There's a 367 down here that is the driver driving those. Let's go ahead and, actually I'm going to, if I can, loosen the heat sink up. And if I can find the screwdriver I want. That nut is really... See if I can do this. The nut and screw are loose. I don't know if I can hold on to it enough this way to break it loose or not. Oh, that's the wrong screw for the nut. So let me just kind of jam that in there. Well, we will put something a little more reasonable in place. I just kind of wanted to wipe the inside of this out. It's just nasty. Just collection of grease and whatever over the years. Let's see if I can find the proper screw. There happens to be a screw laying right there. But that is certainly not it. At least for this nut. Yeah, somebody definitely jammed the wrong. It's a self-tapper that was never meant for how it was used. So let's fix that up and do it right. Let me go grab a hardware bin. And we'll do that a little nicer. Shit. Excuse my French. Sure you heard that fall, and of course it popped open when it hit the ground. Little bin of hardware just got dropped. That's going to be a little too short. That might be long enough. Why can't I get you lined up? Of course, now it's getting a nut that'll fit on that. Well, it felt like the right one till it... Nope, definitely not the right one. Again, definitely not the right one. What the heck? I'm starting to think it's the screw that's got bunged up threads. That's going to be too big. Nope. Nope, that works. So I think I was actually getting unlucky with the nuts. At least I think that. No, that's really not the right nut either. Okay, different kind of screw. I'm tired of mucking with that. Don't want anything super long. What have I got floating around in here? That's not the right nut. But that is definitely the right nut for that screw. Now I'm going to get my big old fingers in there and get this to start. Probably should have included a block washer, but I didn't. That's much better. The heat sink isn't floating anymore. This is really, for the age, really nice card. I need to Get some solvent, remove that little bit of leftover glue there. It's cleaned up well, assuming the voltage regulator is good. We have a bit of a chance of it working. I've got another COM 2502, at least one more in my inventory if that one's bad. Some of these solder joints are really lousy looking. Well, they're okay on the back side. Nice card, gold plated edge connector. Should be interesting. See if we can get this to go. So I think in the next video, or a follow-up video, we will get this in the computer and give it a test and see what we've got. So is what it is. Again, it's a MITS 88 SIOB serial TTY card, or serial TTL card. It's not EIA levels or S232 levels. Is what it is. But we'll see. I'll catch you in the next video.